So, significance test for proportion. So I'll give you a problem here. Somebody did a poll on energy use. Could have been at this school. Could have been someplace else. And I made the numbers up a little bit. They asked 559 people. I just pulled that one out of wherever. If they favored increasing the use of fossil fuels to decrease the cost of home heating. Okay, so and 246 of them said yes. Is this good? Is this good evidence that less than half of the population favor the increased use of fossil fuels?
I don't know.
Let's. Margaret doesn't know, but she wants to find out.
Yes.
So it doesn't all make it to the recording. So let me quote you there, Margaret. Okay. Hi. So we'll do a 4-step test, and step 1 is going to be, since this is a significance test, we're going to name our parameter, and our parameter is not going to be mu. Our parameter is going to be P, and that P is the proportion of the population. I don't know what the population is here. I guess people in San Mateo County, I don't know, who favor increasing the use of fossil fuels. A proportion is like a percentage, but so a proportion is a percentage, so 246 over 559 would be a proportion that you can change into a percentage. Okay?
So it's basically the same as mu, except to say.
Right, instead of doing a mu, instead of doing a mean, we're getting a statistic that is a proportion, not a mean, but a percentage of people who said yes. Okay. Okay. In my step 1, I need to do a null and an alternative. So my null is that the proportion of the population is going to be, is this good evidence that less than half of us favor the increase of use of fossil fuels? What do you think I should be testing against? What proportion should I be testing against? So my 246 out of 559 is a sample. And I'd like to see if that's good evidence that less than half of us favor the increase. I see a proportion buried in this problem, and it's 0.5. Okay? And my alternative is going to be that the population proportion is less than 0.5. Well, less than half. Gave us that 0.5. So sometimes the proportions are kind of buried, and sometimes they're not. Okay? Step 2 is to name the test. This is a significance test, not for a population mean this time, for a population proportion. Now, with proportions with confidence intervals, what distribution do we use? We only use T when we're doing means. We can use the normal distribution. And this is a single sample. We indicated in one tail test by that alternative hypothesis. Okay. My conditions. My conditions need to be that we have a SRS. This was done by a pollster. I guess we'll say sure since the numbers are made up. Yeah, so yes, I did do a simple random sample.
Do you just assume it's normally distributed because there's 559 people?
No, we don't. We don't have the central limit theorem. Thank you.
Then why does it
So for, well, we're going to use a normal distribution with our significance test rather than a t distribution. So
oh,
we
yeah,
indicate that.
Okay,
But our check for normality needs to be that n times p is greater than or equal to 10. And so this is where it's getting a little bit different than the confidence interval. And n times 1 minus p has to be greater than or equal to 10. And we did that before. Our n is, we asked 559 people. And the p that I'm going to use for this check on this condition is not the sample proportion. It is the population proportion that we have hypothesized. So the p that I use is 0.5, which is different than what we did with the confidence interval. But half of 559, which is 279.5, yeah, is greater than or equal to 10. And 1 minus p is also 0.5. So that is greater than or equal to 10. So we're okay with the normality check. And with the independence check, we need to make sure that the population is greater than 10 times the sample size. So the population that we sampled out of needs to be greater than 5,590. Okay, there's my conditions. Okay. So this little check right here would be different if we were doing a confidence interval. Okay. Step 3, I'm going to get my test statistic. In this case, it's always either a t or a z. Since we're using a proportion, we're using a z.
Do all proportions always use Z?
Yes. And that's going to be my sample proportion minus my hypothesized proportion. Some people call this P naught. Divided by Margaret, I think you may need to step out of the room.
Okay, then all the P quiet.
Divided by my standard error, which in this case I'm going to use my hypothesized proportion, times 1 minus my hypothesized proportion divided by my sample size. So what is my sample proportion? It was 246 out of 559. My p hat is the sample that I got. In the sample, I asked 559 people and 246 of them said yes. My hypothesized population proportion